Express x over x plus 2, x plus 3 and x plus 4 in partial fractions. So first let the expression be split up into three separate fractions, one with the x plus 2 as the denominator, the second one as a b over x plus 3 as the denominator, and the last fraction as c over x plus 4 as the denominator. Now if we were to combine these three fractions together, so we can see that there is a x plus 2. So in order to make them have this denominator, we need to multiply the first fraction, the numerator and the denominator, with the x plus 3 and x plus 4. And similarly for b, there is x plus 3 here, but it doesn't have the x plus 2 and x plus 4. So I'm going to multiply the b by x plus 2 and x plus 4. And likewise for c, I'm going to multiply the numerator and denominator with the x plus 2 and x plus 3. So when we do that, all of them would end up having x plus 2, x plus 3, x plus 4 as the denominator. So since they all have got the same denominator, we could combine them and write it as a single fraction. So where a has x plus 3 and x plus 4 as the coefficients, and b having x plus 2 and x plus 4 as its coefficient, and c having x plus 2 and x plus 3 as its coefficients. Now that the denominators are equal, so the numerator have got to be equal as well. So what we have on the left as the numerator, that's x. So on the right side of the fraction, so this is your numerator, this entire string of expression, which is a times x plus 3, x plus 4, and b times x plus 2, x plus 4, plus c times x plus 2, x plus 3. So I have just equated them. Now the thing we're going to do next is, of course, to find out the values of a, b, and c. In order to do that, we could take appropriate values of x and substitute them into the expression in order to eliminate a couple of variables at a time, and so that only one of the unknown a, b, or c can be left. So in order to do that, let's take first of all x as minus 2. If I take x as minus 2, what's going to happen to this particular part of the fraction, particular part of the expression? Minus 2 plus 2 is going to give you a 0. So b times a 0 times anything is of course going to become b times 0, which would make the b disappear. Similarly, if you look at this bracket, you can see that there is a minus 2 plus 2, which is going to turn this bracket into a 0, and c will of course get multiplied by a 0, which would make c disappear, leaving behind only the expression in terms of a. So let us now substitute the x with minus 2. So x is minus 2, and if I go to this, I'm going to write it a times minus 2 plus 3. And then for the second bracket, it's minus 2 plus 4. And as I have mentioned earlier, the b will be multiplied by a 0 and c would also be multiplied by 0. So we can ignore the b and c. So 3 times minus 2 is going to give you a 1. 4 minus 2 is going to give you a 2. So 2 times a 1 is going to end up giving you 2. 2 times a is 2a. If 2a is equals to negative 2, just a would be negative 2 divided by 2, which would give you a as being equal to 1. A is equals to minus 1, because minus 2 divided by positive 2 is minus 1. Now what would be the next number that we need to take that would make a and c disappear, leaving behind just the b only? And of course, if you look at what is common to the coefficient of a as well as the coefficient of c, is x is equals to negative 3. So what would happen if I substitute a negative 3 plus 3 is going to give you a 0, and of course if you look at the last bracket, it will also give you minus 3 plus 3, giving you a 0. So that would make c disappear as well as a disappear, leaving behind only the b. So let's replace the x with a minus 3 here. So minus 3 is equals to a times minus 3 plus 3 is of course 0, so it will be just simply a times 0. And if you look at the last term, c would also be multiplied by 0 because of this bracket. And as far as the b is concerned, coefficients of b are x plus 2 and x plus 4. So if I replace the x with a minus 3 and this x with a minus 3 as well, so what we have is minus 3 plus 2 is going to give us minus 1, and 4 minus 3 is going to give us 1. 1 times minus 1 is going to give you a minus 1. Minus 1 times b is minus b. So minus b equal to minus 3, which would mean b is equals to minus 3 divided by minus 1, which would be 3. So the value of your b should be equal to 3. Now in the same way, we're going to find the value of c. For that I'm going to take x equals to minus 4. So when you substitute x equals to minus 4, we're going to have minus 4 equals to, of course you can see a and b has got this x plus 4 as one of the brackets. So that would make a and b have a coefficient of 0. So we should make a and b disappear. Now if you go to the coefficient of c, so you have got minus 4 plus 2, which is going to give you a minus 2. Minus 2 times the c is going to give you minus 2c. And then here you would have a minus 1. Okay, minus 4 plus 3 is minus 1. So you got a minus 2c times a minus 1 is going to end up giving you minus 2 minus 1 is going to give you a 2. So you're going to have 2c is equals to minus 4. And what would be the value of c? C would of course be minus 4 divided by positive 2. So it's going to become minus 2. So that's the value of c. Since we have already found the values of a, b and c, we have already successfully expressed it as a partial fraction. Okay, by just replacing the a, b and c with these three values of minus 1, 3 and minus 2 respectively. So let us do that. Therefore x over this is equals to the value of a, which is negative 1 over x plus 2, as you can see from here. B, I'm going to replace it with a 3, so this would become 3 over x plus 3. Plus for c, I'm going to replace it with minus 2, right? So of course I have taken the minus to the front of the bracket, front of the fraction, so I get a minus 2 over x plus 4. So we have already expressed this given fraction in partial fractions as a sum of these three fractions. Let us now look at part B. Hence, that means we're going to make use of what we did earlier in order to evaluate this. We are told to evaluate from 1 to n the sum of r over r plus 2, r plus 3 and r plus 4. So how are we going to do that? Now if you look at this, okay, what we had in the previous page was 1 over, x over x plus 2, x plus 3, x plus 4, right? So they have just replaced the x with in terms of r. So this has already been expressed in its partial fraction. So we, instead of writing x, we could write it with the r, right? So it will become minus 1 over r plus 2 plus 3 over r plus 3 minus 2 over r plus 4, right? And of course, if I put the sigma notation on the left, taking from 1 to n, the sum of 1 to n terms. So what we're going to do is, here also we're going to put sum of, right, 1 to n terms of this. Each and every one of the fractions can now be replaced by 1, 2, 3, 4 all the way right up to n, and we can simplify that. And of course we are going to apply method of difference to actually evaluate the value. When r is a 1, what will be the first fraction? Okay, 1 plus 2 is going to become 3. So the first fraction will become minus 1/3. The second bracket will become 3 over 1 plus 3, that will be a 4. So plus 3/4 minus 2 over 1 plus 4, that will be a 5, minus 2/5. So when I substitute r equals to 1, I get a minus 1/3 plus 3/4 minus 2/5. And let's now change the r into 2. So when I change it to a 2, so 2 plus 2 is going to become 4. So the first term is going to be minus 1/4. Second term would be 3 over 2 plus 3, that's going to become a 5. So the second fraction will be 3 over 5, and the third fraction will be 2 over 2 plus 4, which is a 2 over 6. Now if you continue to go into r equals to 3 and so forth, so you would end up writing fraction. Okay, you can replace each time with the r increasing by 1. So r equal to 1 gave us the first row, the r equals to 2 gave us this line, and the r equals to 3 gave us this line, and so on and so forth. We can just go on and on. But okay, what we are going to do now is going to the last few terms. Okay, so the one before n, okay, or the nth term is going to look like this. Okay, this is actually the term before it, n plus 3, right? So we need to have n plus 4. So if the last term, okay, we replace it with the n, the last row, okay, minus 1 over r plus 2, which you can see here, plus 3 over r plus 3, which is, of course, if r becomes a n, so it's going to be 3 over n plus 3 minus 2 over n plus 4. This is what I have. And of course the sequence before it, or the row before it, should have n minus 1, right? So of course if I put a n minus 1 plus 2, okay, that's how I would get n plus 1. So n minus 1 plus 3 would have given me a n plus 2, the term before it, right? The row before it. So this would have been n minus 1 plus a 4, that would have given me n plus 3. And of course, even just by looking at this pattern, we can see plus 4 plus 3, and then of course the term before it should have been a plus 2. So we can actually see how to write the entire expansion of this sigma notation. Now let's look at if there is anything that we can simplify. Okay, now if you look at minus 1 5 minus 2 5 minus 1 fifth minus 2 fifth is going to give you minus 3 fifth, and minus 3 fifth, if you add on to a plus 3 fifth, it's going to become 0. Basically the first term in this row, the middle term in the second row, and the last term in the first row, they are going to cancel out to a 0. So therefore I could just simply cancel them. In the same way, I've got a 2 6 here and I have got a 3 6 here. I would have gotten a minus 1 6 on the next line of numbers, right? So I could also cancel them, and I can just keep going on and on. And if you look at it, in the first line I will have the first term and the second term left, and on the second line I will have only the negative 1 quarter that will be left. So there are 3 terms, okay, that is left from the first and the second row. And of course, if I have cancel everything, so if you go here and take a look at these 3 terms, okay, diagonally across, minus 2 over n plus 2 minus 1 over n plus 2, this is going to give you minus 3 over n plus 2, and to that if I add a plus 3 over n plus 2, it's going to become 0. So therefore we know that these 3 terms can also be cancelled. So that will leave you with only this, and this left. Okay, minus 2 over n plus 3, plus 3 over n plus 3, and minus 2 over n plus 4 left. Everything else in the middle or in between would all have been cancelled off. So now let's remove all those things that has been cancelled, leaving behind this first 3 terms and this last 3 terms. Okay, and we're going to write them. Okay, so I bring the minus 1 quarter up. Let me bring the minus 2 over n plus 3 and the plus 3 over n plus 3 and the minus 2 over n plus 4 together. Now we have got these 3, all 3 of them are numbers, right? So the fractions. So minus 1/3 plus 3 quarter minus 1 quarter, if you key into the calculator or if you just do manual calculation, it should work out to a 1 over 6. So 1/6. Now this one and this one, okay, we have got a n plus 3, 3 over n plus 3 and minus 2 over n plus 3. So from 3 if you subtract a 2, it's just simply going to become 1 over n plus 3, isn't it? Because this and this have got the same denominator, so we could combine them. So it's simplified to give you 1 over n plus 3. And then this one has got a different denominator, which is n plus 4. So I'm just going to keep it as minus 2 over n plus 4. So this is how we can simplify this, and of course whatever the value of n, we can just put it in here and it would help us to evaluate this entire expression here. So this value taken from sum of 1 to n, when r goes from 1 to n, so if you evaluate this expression, it should simply be 1 over 6 plus 1 over n plus 3 minus 2 over n plus 4. And if you wish, you can combine them together. Okay, so here I have resorted to combining them, n plus 3 and n plus 4. We can put it together and combine the fraction. 1 times n plus 4 minus 2 times the n plus 3, which is what I have written as a numerator, because there is a n and a minus 2n, which could simplify. So okay, we have got a 1n and then a minus 2n, and we have got a 4, and then minus 2 times 3 is minus 6. So of course there is a minus n and a minus 6, so I have decently pulled out the minus sign outside. So that leaves the numerator with a n plus 2 and the denominator with a n plus 3 times a n plus 4. So this is the simplification of this whole thing, and for us to gain the 3 marks. Now state the value of this, okay, from 1 right up to infinity. All the way we are going to go to the infinity of the same thing, r plus 2, r plus 3 and r plus 4 on the denominator. So of course the difference between the part 2 and part B and part C is that the n value has now become infinity. So from part B we actually know that if I take from the sum from 1 to n and evaluate this expression, it would have been 1/6 plus 1 over n plus 3 minus 2 over n plus 4. So, but the only difference is that the n has become a infinity now. So I'm going to replace the n with the infinity, and of course if I replace the n here with the infinity, I've got to go to the right hand side of the expression and I have to replace the n also with infinity. So I'm going to have 1 6 plus 1 over infinity plus 3 minus 2 over infinity plus 4, right? So that's what we end up getting. Now what would be infinity plus a 3? Of course infinity is very huge and 3 is not going to make a difference, right? So infinity plus 3 is still going to become infinity. So likewise infinity plus 4, okay, 4 is very small compared to infinity. So infinity plus 4 is still going to give you the infinity. And of course 1 over 6, I'm just going to keep it as it is. This is simply going to become 1 over infinity minus 2 over infinity. So the 1 over 6, let's keep it as it is. What would be 1 divided by infinity? Okay, if let's say someone gives you $1 and asks you to share it with infinite number of people, you're going to end up dividing by extremely a huge number. So what anyone would get would be insignificantly a small amount. It's going to be almost zero. Nobody wants that money, right? So it would be same, right? 1, if you divide by infinity, it's going to become extremely small. It's almost 0. So we can just replace it with a 0. And similarly, if you take 2 and you divide it by infinity, it is also going to become 0. So if you add a 1 6 to a 0 and subtract a 0, so these zeros doesn't really make a difference to the 1 6. So therefore this should be equals to 1 over 6. So if we were to evaluate from 1 right up to infinity, well, which we can simply call it a sum to infinite number of terms of this, it would simply become 1 out of 6. So that is the answer, and if you do that correctly, you will get another 1 mark.